Have you ever thought about buying a used welding machine? How do you know if you're buying a good machine or a junker? Well, I'm going to go through this Hobart Handler that a friend of mine found, and we're going to go through some of the things that I would look for to tell if this thing is a gem or a junker, and whether you should take it home or kick it to the curb. One of the first things that I look for in a used piece of equipment is the brand. And Hobart is a highly recognized brand that's a member of the ITW Illinois Tool Works family along with Miller Electric. This particular unit's a Hobart Handler 175, capable of about 20 volts, 130 amps at 30% duty cycle. If we run it lower, we can probably run a little bit more than that before the machine starts to overheat. But if we're running cranked up at 130 amps, you can only weld for 3 minutes out of 10. And what I'm going to do next is try and figure out how old this thing is. So the best way to start investigating when this thing was built is to look at the serial number. This is on the back of the machine, and unfortunately it's a little bit scratched up right here and we can't quite make out the whole thing. However, if you go to Miller's website and you take a look at their serial number information, you'll find out that LC is a very common serial number that started to be in production in that 286 range in about 2002. So this thing is about 23 years old, it looks like. All right, so this Hobart Handler seems to have a pretty good pedigree. It's a reliable brand. It's been around for a while. These things were pretty bulletproof when they came out. And the next thing that I'm going to look for beyond when it was made and kind of the external condition, which, like I say, looks pretty decent for this machine being a 23-year-old unit, is I'm going to look at whether the accessory package is complete and look at the condition of them before I even open up the case and look inside the box. So let's take a look at the accessories that are kind of wound up here and look like they've seen better days. All right, let's uncoil the leads here and see what we got. This is bound to be a mess, and bear with me as I work through my cordology. Here we've got our MIG gun. This thing is still attached. Looks like it's kind of wound up and twisted in a knot here with a few of the other items. Here's our regulator and gas hose that somebody cared enough to put a thread protector on, so that's a good sign, right? All right. Here's our primary power plug. This thing came molded on from the factory, so it is indeed dedicated to just plug right into it, like I say, a 230 volt plug. Depending on where you're at, you might call it 220 or 240 as well. Looks like we'll be able to plug it in and test it pretty quick. This is our work clamp. One of the most overlooked pieces of equipment in the whole system, and arguably one of the most important next to the MIG gun, right? Because if we're not making good contact and completing our welding circuit, we're going to get poor transfer, we're going to have arc issues, this thing's going to overheat, and it's not going to work as good as it should, right? Will it work? Maybe, I don't know. But at the end of the day, what I see is the contacts inside these jaws are completely gone. And this thing has been using this sheet metal, which is really not rated for the current that we're working on. Probably has some type of a nasty coating on there that could start to burn off. So I'm going to change this work clamp before we do anything, just to make sure that that thing is out of the equation, not causing us any issues. Beyond that, all the equipment, all the accessories look pretty good. The thing looks complete. We're going to have to do a little bit of investigation on this MIG gun because I can see that the end is missing the nozzle and potentially some of the insulators and seals that go on that. So we'll put this thing together and see what it does. We're going to hook a little bit of C25 to it, or 75% argon, 25% CO2, and we're going to see if this thing will make a snap, crackle, and a pop. Well, before we get too far, let's pop open the side of this machine and see what the inside looks like. It is a MIG welder, or gas metal arc welder. It's got wire in it already. Looks like it's been in there a little bit of a while. I can feel rust and see rust on the wire, and where that concerns me is that wire still fed through that conduit into the gun, and if it's rusting on the spool, chances are it's rusting inside the liner, and when we take that thing out, it's going to leave rust and debris behind. So just kind of in the back of my mind, where my head's at is as we're changing parts of the gun, I'm going to probably want to start with a brand new liner just to make sure we don't have any feeding or contamination issues. This is a polarity reversing terminal here. What we have is solid wire, so we're running our positive, DC electrode positive, right on down here to our power pin adapter and we're welding with electrode positive. The reason that we have this inside the machine is most of these little units will run a self-shielded flux core wire, which operates on DC electrode negative. Right now, the negative is going out to our work clamp or to our ground clamp, depending on what terminology you want to use. And if we were to switch these, right, and we run the negative right down to the power pin adapter in this area on the drive feeder, we would switch over to DC electrode negative. And like I say, we would use that for self-shielded flux core wire. This is a drive assembly. And what it looks like to me is we have, let's see, an idler wheel here that doesn't have a groove in it at all. It's a little bit dirty, but hey, looks like it should work. And then down here on the bottom, we have a single drive roll that, again, looks like it's in pretty good shape. There's a little bit of rust that maybe we can clean up. We could get the dust out of there, make sure that's not causing us any issues. As I look back here underneath, I'm seeing, oh, way underneath here, let's get in there. Oh, we got a nozzle, right, that we can try. Looks like we might be able to clean that out. We've got a few extra contact tips down in there that we should be able to use too. So as I cleaned out the bottom of this welding cabinet here, I actually found 3 different nozzles that have been used and a handful of contact tips here and some other garbage. So we're going to clean all that out. But I just wanted to point out, right, we're going to have to look in here and see what these are. These are definitely used contact tips. We don't know the shape that they're in, but by the condition and what I'm seeing here, they're probably junk. At the end of the day, would they work? Maybe, but we'd have to get all the spatter off that tip because that's going to cause us some feeding issues. And if we're not feeding wire, we're not MIG welding. So what we want to make sure is the contact tips that we do put in there are new, clean, and fresh, so we have the best chance of feeding wire through that tip without issues. I found a couple of different tips with wire stuck in them, and that tells me that whoever was using this last had some issues with wire feeding. It definitely could have been because of the scale on the wire or scale loading up in the system and preventing the wire from feeding through. At the same time, could this be that them contact tips got so much spatter on them that it started to grab the wire and then we couldn't feed wire through the tip, so it ends up being an issue, causing a bird nest back in here, right? We're overfeeding the wire with nowhere to go, and we end up going through consumables. So we're going to try to set this thing up and see if it'll weld. All right, so as we're setting up here, I know I mentioned the work clamp and the fact that this thing has certainly seen better days. I am not going to attempt to use it because what do you think's going to happen if we try to make a connection here and we connect to our work, right, with this junker of a clamp? It's going to generate excessive heat in this area because it's not going to conduct electricity the way that it should, and that's going to affect our welding arc. Most people don't understand that if we've got a bad ground, it's going to generate heat, it's going to lose conduction, and we're going to have an unstable arc. Now, 9 times out of 10, you might say, hey, I've welded with a work clamp that looked just like that and had no issues. Well, good for you. But most of the time, these things are going to cause issues. And in my opinion, we have to start out with best case scenario so that we can see if this thing welds, right? We want to start out in the right ballpark and not with things working against us. So that's where we're starting. I'm going to put on a new clamp. So this work connection doesn't have a quick connect where it would attach to the front of the machine. Instead, it attaches actually right to that negative stud that we looked at before. So the easiest thing for me to do at this point is I'm going to try to take this cable off and just put the new clamp on the end and not mess with our wiring, because the wire actually looks like it's in pretty good shape. There's no cuts, there's no nicks, there's no abrasions, and the rubber doesn't feel all junky. So I think if we can get this off, we're going to be in better shape. Otherwise, I'm going to have to go in and either disconnect it inside the machine and find a lug that's the same size to squeeze in there, or I'm going to have to come just behind the clamp, cut it off, resplice it, and make a connection. And if I don't have to do that, I'm going to be happy because this is going to go a lot quicker. All right, let's take a look if our impact will pull this off. All right. Well, we loosened it. That's the good news. The bad news is we got to get all the way down inside this ugly clamp and get a wrench on that to get this thing off. All right, so I've got a new work clamp to try here. This one, as you can see, is quite a bit smaller in physical size than the one that we took off, which tells me, one, this is probably an aftermarket clamp that somebody borrowed from a different system and threw on there, maybe because the first one was damaged. In the case of this is a lot smaller. It's probably got about the same output rating. And I just want to point out a few things about this work clamp. This one has contacts, like I say, that we're missing off of this one. So it's going to give us a lot better connection when we connect it to the work, helping to complete the welding circuit. Couple of things that you may or may not know. These things have a coating on them, and when they get hot, they're going to start to burn. I've seen galvanized where it burns kind of blackish, brownish, and leaves a yellow residue. If you start to notice that, you have a work connection issue where we're generating too much heat here. This thing looks super high quality. But I want to point out another thing. Although these appear to be copper, I'm going to tell you, my hunch is they're not. And how would you know, right? They look like copper, they shine like copper, and when we see copper on these connections, we falsely assume that this thing is a high quality work clamp. But, is it? Huh. That's pretty magnetic, folks. All right, one way to tell of what we're working with here is to actually take a file and scratch on into it. Right? If we file through that outside coating and it looks like shiny steel, it's probably shiny steel, right? So this thing has been painted to appear to be high quality, and arguably this work connection strap here does give us a little bit better connectivity as we're going from the top to the bottom, right? So we do get a little bit better performance than the original clamp that was on here. But don't kid yourself. This is not copper. This is actually a coated material. I wonder, right, what the resistance actually would be here compared to bare material. It may actually be better if it was unpainted altogether. I'm not sure, but I know that when I started looking at these clamps initially back in the early 2000s, I was under the perception that that they had been improved upon over the galvanized clamps that'll actually get hot to the touch while you're welding. But unfortunately, I was let down when I saw this. So at the end of the day, it's going to work for what we're trying to do. We're not running 1,000 amps through it. This thing is a 130 amp welder, 175 top end. So chances are we're not going to overheat this clamp as long as our connection's good. So while we're on the topic of work clamps, let's dig a little bit deeper into what I would recommend for a work clamp, especially in an industrial setting if we're running higher current, right? If you're doing any pulse welding or anything like that, you're going to want to upgrade. So what's the best work clamp you can have? Well, in my opinion, it's something that looks like this. This is a 100% brass clamp. It has a C-clamp type action, so we can lock that thing right on the part. Because, dude, you do not want your work clamp coming off and accidentally becoming the path from your electrode to your ground, because that can zap you. So we want to make sure that our work clamp is solidly attached to the material that we're working with. This is overkill probably for the home shop, but at the end of the day, I've got a Dynasty sitting back there, and I'm not running anything but the best on it, right? So take a look, try to find a brass clamp, something that is brass and actually has really good conductivity, right? This is heavy duty brass. This should not get hot while we're welding, and it's attached to a 4-aught lead, so I can run just about as much current as I want through there realistically. We have functional, but probably not the best. Maybe a little bit better, kind of small, but at least it's got a little bit of a strap there, even though it is not actually copper. And then we've got our heavy duty brass clamps. You can buy these as well with a similar function, right, with these scissor clamping devices, but if you can, get something that locks onto the material. Alrighty, feed our lead through here just like that. We arguably could use a new terminal ring there, because as I was grinding it, I got a little bit into that connector, but this should be good enough just to give us a test. We're good. Okay, got a new work clamp on there. We're getting closer to be able to run on a test weld to see if this thing functions. Once we know it functions, we can go through and upgrade any of the accessories that we want, buy new stuff, replacements, whatever we need to do to make sure this thing is functional, ready to go. But I'm not going to put any money into it until I know if it makes some sparks. So first thing I'm also going to do, because this wire was rusted on the outside, I'm going to snip it right here. All right. Do not let go of that wire or you will have a big mess on your hands. Ask me how I know. We're going to pull that thing off. Oh, hey. I can't tell. I thought that was maybe some dust, but it looks like a Brillo pad that somebody put on there to wipe the rust off while they were welding. How do you avoid rust on the wire if you don't use your machine all that often? That could be a problem that you run into, especially where I'm at in Michigan, and it's high humidity all summer. Well, what the wire manufacturers recommend is that you save the original packaging, and when you're not using the wire, take it on out of your machine, put it back up in a plastic bag, seal it up, and put it on the shelf so we keep moisture away. You could also take a couple of them little desiccant containers and you could throw it in there to absorb moisture, and it would help your wire last a little bit longer. As I look at this reel here, it's not very tightly wound, and that lowers my confidence that we can just peel off wire and get down to a clean layer and start welding with the same spool again. While it's certainly possible, like I say, because it's not very tightly wound, I got my doubts. Okay, so another thing is we're looking at the wire, right? Our wire is going to flow on out through our MIG gun, through our contact tip. So I'm going to pull this contact tip out in there. Ooh, maybe. If it hasn't become welded to the diffuser, right? It is slowly turning out, but I cannot move it by hand yet. Oh, there we go. And what I'm going to do is I'm going to pull the wire out from the gun. I'm not going to pull it back into the gun because chances are we're going to pull trash into that liner. And if that liner is functioning at all, we might screw it up, make it not work. Right? So we take this thing out, and I'm just going to pull that wire out. And either I'm scraping the rust off the wire as I pull it through that liner, or it's not in that bad a shape. I would have expected, with the condition of the roll of the wire, for the wire in this gun to be a lot more rusty. But it's not, so maybe we're in luck. All right, we'll throw that out of the way there. We'll clean it up later, right? Okay, what I have now is I have the end of this thing. It looks like the diffuser is fairly clean. I don't see a lot of spatter in there, nothing clogged. Just a little bit dirty, right? So how do we clean that up? Well, I'm going to get a little wire brush, and I'm going to real lightly wire brush around the outside of that thing just to make sure we got it as clean as possible. All right, here we are. We've got our stainless steel wire brush, and we're just going to real lightly clean the garbage off this thing. Dirt, grime, dust, debris. So we can start out in as good a condition as possible, which means our welds are that more likely to be good, right? Assuming I can pull the trigger and follow along the joint. If you start out with a bad setup, you're a heck of a lot more likely to have issues when you're welding, and the smallest thing can cause the biggest issue. So we always try to crawl, walk, run when we're doing this kind of thing. We start out slow. We make sure that we're following best practices. Because like I say, one little hiccup could throw your whole game off, and then it's going to leave you frustrated, and your job's not going to get finished, right? So that's where we're at. This thing looks pretty good, pretty clean. What I want to see here, some of these nozzles are kind of ugly, but we're going to try to see if they'll fit on there, and it looks like they do. So if that's sealing in there good, we should be able to weld and not have a problem. What I'm going to do with this nozzle, though, I don't know if you can see through there. That's my pet peeve. Just ask any of my students that have taken my MIG class. Clean your nozzle, right? Several times a shift, several times a day, certainly before you start. It is the source of your shielding gas, right? Coming out the gun. So if we have spatter buildup on that nozzle, one, you're going to disrupt your gas flow. You're going to have a lot higher chance of having porosity or other weld inconsistencies. And two, have you priced one of these things lately? The last time I bought a nozzle, it was over 15 bucks. So I don't know about you. I keep them as clean as possible, keep that spatter from building up on the inside, and these things will last a long time. If we're talking about little, $1 contact tips, you go through a couple of them in a day or in a shift, that's not terrible. But if we start burning up nozzles because we're sloppy or we don't take care of it, then we're just wasting money. All right, so as we continue our cleanup, I'm going to get out the shop vac. I'm going to vacuum out the cabinet. I'm going to get the dust off. and just try to get this thing as clean as we can. You may be tempted to go ahead and just use compressed air and blow this thing out. And younger me would have done the same thing, and I'd have been covered from head to toe in dust from inside this cabinet. So before I do anything with an air gun or compressed air, I'm going to use a vacuum cleaner and try to minimize the dust that I create in my shop. There's a little trick I learned from a car detailer. Okay, much better. We're gonna have to clean up the contact tip here because I don't have any of this particular style. This one actually doesn't look too bad. I'm just gonna clean the end off with a little sandpaper, make sure there's no spatter on it, and that the hole doesn't look too oblonged, right? Because that hole in the center here should be round, and one of the ways that we know it's worn out is when it starts to get a little bit oval, right? And that can grab your wire, keep you from feeding wire, which means you're not MIG welding, right? So we got to have a good contact tip in there. Fortunately for what we're doing, just testing functionality, this is going to be fine. But if I was going to do a project, I'd want to have, you know, half a dozen of these things sitting inside the box or over in my tool chest so that when I started to have feeding issues, I could easily change it out and keep going. Now I have some extra wire that we could throw on this, but just for grins and giggles, what I'm going to do is I'm going to try to start peeling wire off this roll, and real carefully, right? So that I can see if there's any good wire down underneath here, okay? So let's just keep peeling, keep peeling. The wire's looking brighter as I go, so that's a positive sign. I can feel still a little bit of rough corrosion or rust on the outside of the wire, right? So we're gonna definitely need to keep going. But if we can save any of this spool, it'll be money in the bank. And I'm just curious to see how deep the rust goes, as I'm sure many of you are too. It's like watching paint dry, isn't it? Maybe I should speed things up. All right, well, like I suspected, we've got an issue with a non-tightly wound spool, and the deeper I go here, the heavier the rust is getting. So unfortunately, I'm thinking this thing's gonna go in the hopper, right? Right. Never say die. I continued and continued and continued to pull wire off this reel until I got down to where it's mostly clean metal. I don't know if you can see this or not. I'll try to show us more of a close-up in a minute. But as we're looking at this, I can see spots of rust, even though most of it's gone. This is going to give us a chance to just run this wire, see if the welding machine works, and then we can decide what to do from there. However, on the other hand, just know that as I'm running this wire back through with some of that corrosion on there, anything that doesn't come off the wire is going to make it inside the liner. Could plug the liner, it could plug the contact tip, it may change weldability. So if you've got a welder at home and this is what your spool looks like, my recommendation is maybe next time buy a smaller spool. And second, really consider if you want to open yourself up to having feeding issues. Like I say, we don't even know if this thing works yet, so I'm far from thinking that we're causing any issues. We're just going to use this roll of wire, make a couple of different welds, and if it looks good, we'll change it out and we'll go from there. There's a little sneak peek behind the scenes at all the wire that we had to pull off. This looks like a broken slinky, if you ask me. All right, now that we found a little bit of clean wire, we're gonna go ahead and put our spool back on here, and we're gonna feed that wire all the way out through the gun to the end by hand, just to see if it feeds good, right? If there's any hang-ups in there, any obstructions, any issues with that liner, in theory, we should feel them as we're feeding the wire through by hand. All right, so again, once I do this, right, we do not want to let go of that wire. There's a little tab right here that's going to hold our wire on. There we go. And then do not forget this retaining ring. If you don't put this retaining ring on, there's a chance that that wire could walk itself right off, fall onto the floor, split open, and become an even bigger slinky problem. Ask me how I know. All right. So we've got that thing put back on there. What we're then going to do is roll this thing around so that our wire's coming out and going straight into that area. Then I'm going to take my welpers here. I'm going to clip it off so I got a brand new chunk of wire with no kinks in it. We're going to go through our inlet guide, right, into the drive roll housing here. Let's see if I can lift that up. And into that liner right there. All right, so this take a little bit of time to feed this through here. I've got the gun in a big loop so that it goes out, around, and back on up so that we hopefully don't run into any kinks or obstructions. Remember, the straighter your MIG gun, the easier the wire's going to feed, and that's all we need to do, right, is feed that wire out the end of the gun. So far, this thing's going through there pretty darn easy. I can feel the brake is set right here so that when I let go of the wire after pushing it, it stops and doesn't freewheel, which is important, right? We want to be able to pull wire off the spool, but yet we want it tight enough that when we stop pulling, we don't get that freewheeling. That's going to cause a major issue. So make sure that you have your brake tension set right, and I can start to feel this thing getting near the gun. So far, we've hit no obstructions, which means we might get lucky. You can also feed this through using the drive system. We could close the drive roll doors, pull the trigger on the gun, and let the drive roll do all the work. But like I say, I'm trying to feel the liner in there to find out if there's any obstructions. And this is one of the best ways, is to actually use the feel of pushing. And I got news for you. If you can't push wire through by hand, neither can the drive rolls. So this is a great way to start out. Another thing that could happen is when I'm feeding through with the drive rollers, if there's any obstruction, or let's say we left the contact tip in the end of the gun, as soon as that wire gets off just a little bit and catches something in there, it's going to bird nest back at the machine. And I got to tell you, that can be a frustrating situation, especially if you don't quite know what caused it. Now, it just so happens our wire just poked right out the end there, so we are ready to put our contact tip in, put our nozzle on, hook up our gas, hit the power, and make some sparks. All right, so I was able to clean up one of these contact tips, get the spatter all completely off the end of it. It looks like we've got a nice orifice in there. The wire is going to slide right through there now, and we should be able to use this contact tip for our test weld. Once again, as we get set up to do a little bit more work, and we know this thing is functional, I would buy a complete new set of front-end consumables, probably a new diffuser, a new nozzle or a couple, and a bag of contact tips so that we're ready to rock and roll. We are running 030 wire, and this is an 030 contact tip. So I think we're in good shape, and we're going to go ahead and keep moving forward. Now, as we assemble our gun here, I just want to point out the proper way to install your contact tip. Again, I've got a little bit of wire hanging out the gun here from that diffuser. I'm going to slide the contact tip in and thread it into the diffuser. This one happens to be a threaded one. Several kinds of contact tip configurations out there. And we get her threaded right in all the way. And the function of the contact tip, folks, one, it guides the wire, right? So we've got a small orifice in the end of there, kind of directs the wire toward the joint. Secondly, it's where our main electrical connection occurs, and they say that's where the wire is energized. So we have to have a real good connection between our diffuser and our contact tip so that we're transferring the current down to the wire. So once I get it in there snug, again, I'm going to take my welpers, I'm going to grab them with the contact tip part, and I'm just going to give them a nice snugging so that that is tight. We don't need to go crazy, but they do need to be more than finger tight. Another one of my pet peeves is walking into a welding booth, grabbing that contact tip and walking it out by hand. That is definitely a loose connection that's going to cause extra heat buildup in the gun, and it's going to be a source of a potential erratic arc, especially as we start to do higher amperage processes and or pulse MIG welding. So make sure you got that thing locked in there. You'll get the best performance out of your gun. Okay, moving on in the system, the next thing that we're going to look at is our shielded gas regulator. right? The function of this thing is to take your storage pressure from inside your cylinder down to a working pressure that's more appropriate for our shielding gas, right? And this happens to be one of our, I'm going to call it an economy style, where it's really a flow gauge, where we're using a relationship between the pressure and the flow rate. It is definitely more economical, something that's going to work for us, probably adequate for most of the home jobs we might be doing with this type of a machine. But if you can upgrade and go to a true regulator flow meter, right, something with a tube on it, you're going to get a lot more accurate flow, and you're going to have a lot more high quality device. Now for the moment of truth. We've got our wire fed in, we've got our contact set up, we've got our nozzle on our gun, we are ready to go. We've hooked up our shielding gas, we got the power connected to it, and now I'm going to hit this power switch and see if the fan kicks on and see if we are energized and ready to weld. Okay, we've got our gun all ready to go, it's all assembled. Our wire is in good shape, fed all the way through the gun. We've got a new work clamp on this thing, and I've hooked up our shielding gas, so we are ready to try it. This is the moment of truth. I just turned the breaker on. Let's see if we can get this thing to power up. And there we go. You can hear the fan kick on. This thing's letting us know that it is ready. I'm going to pull the trigger on the MIG gun. And nothing happens. Okay, so stranger things have happened with welding equipment. Sometimes it leaves us scratching our head. I just happened to adjust the wire feed speed knob here and change my voltage tap, and all of a sudden the drive roll started to move. So we must have found a sweet spot, and maybe we can get this thing to feed wire and weld after all. I sure hope so. All right, we've got the welding machine all ready to go. I looked on the inside chart, and it said that if we're welding 1/8 of an inch carbon steel with ER70S6 solid wire steel electrode and C25 shielding gas, we should be at voltage tap number 3 and at about 80 on the wire feed speed. These are just arbitrary numbers. They really don't mean a whole lot. It's basically just a setting as a reference. So I won't be able to tell you exactly what my welding current is. There is no feedback on this thing, but we just have to trust that it's going to be in the ballpark, and then we'll look at our weld and we'll evaluate from there. So what I've got here is just a little piece of scrap angle iron. I didn't clean it up real good. Like I say, I've put some time into this welder and wasn't sure if it was going to work at all. So we're going to hook our work clamp directly to this piece. That way we know we've got a good connection, and we're going to try to make a weld here. All right. Here's our work clamp, welding gun set up. Just going to make sure that our gun is locked in there. All right, wish me luck. Oh yeah, we're making sparks now. Well, I don't know about you, but that sounds like a beautiful sizzling short circuit weld to me. And I think there's not a whole lot wrong with this welder. And if we get it cleaned up, add a few new accessories, upgrade some things, replace some of those wear parts, this thing could keep on welding out in the shop for a long time. Okay, so we got this thing welding. I think that we indeed have a gem here and not a junker. Once we worked through the system, we made sure that everything was working right. We were able to power it up and make a beautiful short circuit MIG weld. You can see on there, we laid a couple of beads. The weld sounded great. We had no problems with wire feeding or other issues. So I think we're going to go ahead and make some upgrades to the necessary accessories and consumables, and we're going to run this thing as much as we can. I just want to point out one thing that, and you know, we were working with the work clamp here. We made a couple of short welds, and I'm already feeling heat build up in this thing. In fact, the lead is almost too hot to the touch. So I think I was right. We definitely need a new work clamp and maybe a new work lead here. In addition, we're going to go ahead and replace the nozzle, the diffuser, and get a new set of contact tips just to make sure we're in good shape. Right now, this weld neck here, the gun neck, has some decent insulation on it, but as this stuff starts to peel and fray back, it might not be a bad idea to keep an eye out for another MIG gun. All right, so just a quick recap here as we evaluated this used welder to find out if it's worth anything and if it definitely is something that would work in the shop, especially something around home or around the farm. And I think we've got a gem here. This unit is an older style transformer machine, which means they're relatively robust. They're a little bit bigger than a current modern machine, but also have a lot less sophisticated electronics. So my hope is that this thing is an older design and it's still working. It should continue to work for a long time. A few things that we looked at. One, overall condition of the machine. You can tell this thing's dusty. It's not scratched up. It's not banged up. It doesn't look like it was dropped. So aside from sitting in a shop and collecting a little bit of dust, this thing looks like it's in pretty good shape. It is a Hobart brand. This product was probably built on the same line as some of the blue machines at one point and shared a lot of the same components. So I feel pretty confident that this thing is a good quality machine. It's worth a little bit of an investment. And if we need to replace any of the common items, we're probably going to be able to find parts for it. So that's a good thing. Just keep in mind when you're buying a used piece of machinery or a used welding machine, you want to make sure that it is in good condition, that it is complete, and that it does weld, because in the case of an older welding machine or an off-brand welding machine, once those things pop and don't work anymore, you're probably looking at a new unit because they don't sell a ton of parts for those, and if they did, it'd be so expensive to replace, you may be better off picking up another one. At the same time, if you can find something relatively robust like this and it's in good working order, you can save yourself a few $100 and get yourself welding pretty quickly. My first machine, the first welding machine that I ever bought, was a used machine. It was a Syncrowave 350 that I picked up from our local welding supply here in town, and I happen to know the salesman. He told me it was like new. Sure enough, when I got to inspect it and look at all the accessories, this thing had maybe 20 hours on it, and I was able to pick it up for a good deal. And I believe that Syncrowave, wherever it may be today, is still running. Just be cautious if you're going out and you're shopping for equipment, because sometimes these relatively simple machines may have something wrong with them that is too costly to repair. In that case, you're not going to want to throw any money into a unit that doesn't have any warranty. So think about that. Think about what you're going to end up doing with it. Think about how much you want to stick into it. And at the end of the day, making sure if it's not working that you can get parts for it. Otherwise, it's not a gem, it's a junker, and it's not a welder, it's a boat anchor.